Hello, mathematicians. It's Mrs. Post here. Today is Monday, April 13th, and we're going to continue working on multiplying radicals. So we're going to use what we started last week and we're going to add to it. Our goal is to get you to where you can actually solve radical equations. So we're going to work on solving these square root or nth root, whatever kind of index you have, but you're actually going to solve these with an equal sign, solving for a particular variable. And the reason why is because I see that on the SAT. I'm going to make sure you guys are aware of that before summer comes, for those of you who are taking your SAT at the end of the school year or during the summer. Okay, so that's why I want to go over this with you guys. I want you to be aware of how to do it. But the first thing you need to know is I need you guys to feel comfortable with radicals and simplifying them. I worked on it last week and you guys worked on the factor tree method, which I think most of you guys liked better. So let me go ahead and show you the product property of radicals and how this is going to work. So let's see. Product property of radicals. So right here, I'm going to show you guys what that means. So let's see, you're going to have, let's say you have any index. And what this means is, let's say you have one radical and you have another radical with the same index. It means you can go ahead and multiply them together. So A times B, which will give you whatever that is. And if you can simplify it, you can. But I want you guys to be aware of, you can take them apart and put them together, or if you have them together, you can split them up into two different radicals. Okay, so we're going to use that today. Let me show you with a number what that would look like. All right, so let's say you have a cube root of, let's say 2, and you have a cube root of, let's say 2 squared, which is 4, and you want to multiply those. You can. They have the same index. So you can take the first one, which is really like 2 to the first power, right? 2 is the same as 2 to the first power. And you can multiply that times 2 squared. And when you do that, you get a cube root of 2 cubed. And the reason why we do that is because this is really handy. So remember, if you have the same index and the same power, you can simplify it and break it down into just one of those. And that's it. That's why you would do that. So we're going to do that some more. These are the steps we're going to use today. I'm going to go over these steps as we go through them. So let's go ahead and make sure you guys are able to write this example down. Make sure you're able to either print out or open up these notes, write this down, and you can do it on your screen, your technology, or you can just go ahead and do it in your notebook. Okay, so we're going to start with example 1. Oops. All right, guys, so if we're starting with example 1 here, I'm going to give us a little bit of room. So if you notice example 1, they have the same index here. So we're going to start with step 1, which is the product property of radicals. Let's go ahead and bring them together. Let's go ahead and do step 1. So if that's the case, you have a 5 on the outside. Just notice you could have a number on the outside that's just being multiplied. Because you have the same index here, they both are a root of 3. You can go ahead and you bring them together. So that's 100a squared times 10a. So that's step 1, just bringing them together. Okay, and then you can go ahead and work with your numbers and just kind of try to rewrite them so everything has, if you can, try to get it to where everything is a power of 3, just kind of like what we were doing last week. So I'm going to do that. I'm going to take my 10 or my 100 and I'm going to write it like 10 squared. All right, and you already have a squared kind of rewritten. 10 really can't be rewritten any other way, nor can a, because they just have a power of 1. I'm just seeing some similarities. This is where you guys are really manipulating it and trying to get everything so they have a power of 3. It's kind of cool when you do that. So hopefully you'll notice this is 10 to the power of 1. This is a to the power of 1. And once again, hopefully you guys are noticing that we're able to group everything into the same power. So now we have a cube root of 10 to the 3rd power times a to the 3rd power. And now everything is to the power of 3 just by rewriting it. And so we're able to go ahead and use the product property of radicals and write this now as separate radicals. We have, this is really like times. Just know that this number out here is really just being multiplied to whatever is on the inside. It's kind of like a coefficient or kind of just sticking off to the side. So you can look at it like a 10 to the 3rd being multiplied times another cube root of a to the 3rd. Okay? And so when you do that, hopefully you guys are noticing that we still have the 5 here, this right here now becomes 10, and this right here now becomes A. So when we simplify this out, and we went ahead and simplified it, now we can just multiply it. 5 times 10 is 50. 50 times A is 50A. So what your goal is to look at the index and try to write every single factor inside your radical as the same as the index, which is what we did last week, okay? So just make sure you guys are trying to follow those steps. I think I was able to do that in 6 steps. So you guys could kind of compare them and see how I did it. We're going to try to do the next one with the same amount of steps too. I know it looks like a lot of steps, but I'm just trying to show you how they led to the other. So we're going to go ahead and go to example 2. And if you're stuck, you can always go back, pause, watch it again. Okay, let me go ahead and start you guys off with example 2. All right, so with example 2 here, we're going to do the same strategy. We're going to go ahead and bring our radicals together because if you notice, your index here is 2 and your index here is 2, right? It's just a regular square root, so you don't really write the 2. I'm going to go ahead and put my coefficients together, my 6 and my 4 on the outside here. And then I'm going to go ahead and bring everything else together, just like we did on step 1. So that means we have 8c cubed d to the 5th times 2c d to the 3rd power. All right, so I'm just rewriting everything like that. Okay, so that was our step 1. Step 2 is to go ahead and to factor your constants, to go ahead and try to write your numbers out, kind of split them up if possible. And this is a square root, so we want everything to the power 2 if we can. So I'm going to go ahead and multiply my 6 times 4 just to go ahead and get it over with. So 6 times 4 is 24. So we just have this 24 kind of sticking out to the side, okay? Don't worry about it for now. We'll work with him on the last step, just like we did with the 5 up here. All right, so I'm going to write my 8. I know 8 is the same as 2 times 4. So I'm going to write him a little bit different, though. I'm going to write it like 2 times 2 squared. Right? Because 2 squared is 4, 4 times 2 is 8, and I know this is a square root, so I'm trying to get everything into a power 2 if I can. All right, so now whenever I do that, I also still have c cubed and d to the 5th, and I have a 2 and a c and a d to the 3rd. All right, so far those guys are kind of staying the same. All right, I'm going to bring down my 24, just kind of hold them. Just bring them all the way down to the end. Now I know over here when I look at it like this, I actually at this point have a 2 squared from my original, but I also have a 2 here and another 2 here. So really that's another 2 squared, okay? And then I have, at this point I also have c to the 4th, and I also have d to the 8th now, okay? So we had c cubed and c, so that becomes c to the 4th, and d to the 5th, and d to the 3rd, which is now d to the 8th when you add your powers. Okay, I'm going to try and see if I can, I don't think I can squeeze this on the same line. So now I'm going to go ahead and use the product property of radicals, and I'm going to split everything up, like how we did over here, where you split them up into separate pieces. I'm just going to bring it down here. So I have my 24 on the outside who's just hanging out. I'm going to break everything up. So I have 2 squared, and I have another square root of 2 squared, right? I have this one, and then I also have a square root of c to the 4th, and I have another one with a d to the 8th. Remember, this is just a regular square root, so I'm trying to get everything into powers of 2. So hopefully you guys can go ahead and break that down. So you have 24 times, this is a power 2, so that becomes a 2. This is also a power 2. So this also becomes a 2. Remember, this is also a power 2. Remember, you can also write that like c squared squared. So that now becomes c squared. And then you also have d to the 8th over here. And remember, that is the same as saying d to the 4th squared. And so when you simplify that, you get d to the 4th. This is what we've been doing for a couple of weeks now, so I'm not going to go over that again. And so now you can look at it like 24 times 2 is 48, times another 2 is 96, c squared d to the 4th. And that would be your final simplification right here. Okay? You can pause the video and go through those steps again, but we went through all of that in 6 steps also. All right? All right, I've got one more example for you guys because it has a negative in it, and it's also a cube root. And then I have one assignment for you, a problem for you guys to do today. So let's go ahead and use the same steps. I'll actually recommend that you guys pause the video and go ahead and try this problem out and see if you guys can do it. Okay, so hopefully you guys were able to go ahead and rewrite this one with your, let's say, your coefficients on the outside, your 5 and your 3. And remember, this is a cube root. So it's okay. You can go ahead and bring everything together. So you have negative 12 a b to the fourth times 18 a squared b squared right here. Okay. Then you guys can go ahead and multiply the 5 times 3. Just go ahead and get it over with. And then you guys can go ahead and start rewriting all of your factors, hopefully in some way as a power of 3, if you can. So I know 12 is 3 times 4, right? And so because I know it's 3 times 4, I know I'm going to go ahead and break it down like that. So I'm going to do, you can do this a couple different ways. This is the way I'm going to do it. I'm going to do negative 2 squared. It's like really like a negative on the outside there, times 3. Because when you say 2 squared is 4, 4 times 3 is 12, times a b to the fourth times, I'm going to do the same thing with the 18. So I know 18 can be broken down into 2 and 9, and I know 9 is 3 squared, right? And I'll go ahead and keep my a squared, b squared. All right, so let's see if we can kind of take this down a little bit further. All right, let's try and group everything to where everything is a power of 3. All right, so I had a negative over here on the outside. Just remember he's there. We had a 2 squared here and then another 2. So really that's going to give me 2 cubed, right? Look at that, we have a cube. And then we're going to have, we have a 3 here and then 2 3 here's. So that's going to be times 3 cubed. And let's look at our a's. We have an a and an a squared. So now that's a cubed. We have a b to the fourth and b to the sixth. That's actually going to be b to the sixth power here. Okay, so we wrote everything now as with everything to the power of 3. So now with most everything to the power of 3, you guys can rewrite everything a little bit separate. So we have our 15 kind of hanging out. We have our cube root of negative 2 cubed, and we have our cube root of 3 cubed. We have our cube root of a cubed, and we have our cube root of b to the sixth. So remember that we can go ahead and look at this like it's a negative 2 cubed because you can actually do that because a negative times a negative times a negative is actually still a negative. So you guys can look at it like it's a 15 times a negative 2 times 3 times a times, hopefully you guys remember this over here can be written as b squared to the power of 3. So that would actually be b squared right here. So when you multiply all of that together, you guys should end up 15 times 2 is 30 times 3 is going to be negative 90 a b squared. And that is it. And hopefully that's what you guys got for this example. Now what you guys are going to do, you have a really quick assignment for today. It actually looks like this. It's one problem. I want you guys to try this for today. This is you try, and this is all I need you guys to do. So if you guys can go ahead and do this problem today, it'll be posted underneath assignments. You can send it as a Google Doc. You can write on it. You can send it to me on a piece of notebook paper, whatever you prefer. And you guys go ahead and work on that and have a great day. And I will talk to you guys later.